Alright, video number 6 now. We're going to talk about kites. We've been talking about quadrilaterals, parallelograms. Now we're talking about a different quadrilateral, and that one is called a kite. Kind of like what you fly in the air, right? Same type of shape. But your learning target is I can use properties of kites to solve problems. Alright, so let's first define what a kite is. And a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. Two pairs of consecutive, meaning they're right next to each other. Those sides are right next to each other. Congruent, meaning they're the exact same length. Two pairs of consecutive congruent sides. Okay, so there's three theorems that go along with these with kites. Okay, and the first one is that the diagonals are perpendicular. Okay, perpendicular. That means that right here where the diagonals connect from A to C and B to D, right here at this angle, it's a right angle, 90-degree angle. That's what perpendicular means. The second theorem in this is that one pair of opposite angles are congruent. One pair of opposite angles are congruent. That angle is going to be the one that lies in between not the consecutive congruent sides, not this angle, but the one in between the two sides that are different, angle B and angle D. Those two angles are going to be the exact same angle measure, okay? So angle A and angle C are not congruent. Angle B and angle D are congruent, okay? And this last theorem is that one diagonal bisects the other diagonal, okay? One diagonal bisects the other diagonal. Okay, so if we're looking at this kite here, we've got AC and DB. Those are your two diagonals, and they cut this long one, the main huge diagonal there. Let me move this down just a little bit. The huge diagonal is going to bisect this shorter diagonal. So that means AE has to be congruent to CE. All right. That's what that does. Alright, so we're going to use what we just talked about with those theorems of kites, and that's going to help us understand what we're doing here for this first example, okay? It says Lucy is framing a kite with wooden dowels that measure 18 centimeters, one dowel that measures 30 centimeters, and two dowels that measure 27 centimeters, okay? So we see that we've got the two dowels right here, those are your 18s, 27s over here, and then the long cross piece right here is 30 centimeters, okay? To complete the kite, she needs a dowel to place along KL. We need another dowel to place in this length right here. And she has a dowel that is 36 centimeters long. About how much wood will she have left over after cutting the last dowel? So we want to see how long does this need to be. If we have 36 centimeter long dowel, how much do we need to cut off of that dowel, right? So to figure this out, we have to know certain things about this kite. And like the theorem said, these are right triangles. These are right triangles, which means in right triangles, when we have right triangles, we know certain things about right triangles. We know that Pythagorean theorem works on these, okay? We also know that this long diagonal is going to cut this diagonal in half, which means that if it's 30 centimeters, this whole diagonal is 30 centimeters, this has to be 15 centimeters as well as this other side too, okay? So now that we know that, we can actually figure out, using Pythagorean theorem, what the distance is from K to this center point, and what is the distance between L and that center point. Okay, then we can figure out all this stuff. So let's go ahead and do that. We know that in a kite, or in Pythagorean theorem, we have a squared plus b squared equals c squared, where c is that hypotenuse. That means 18 centimeters is going to be our hypotenuse. So I'm going to do the work down here. We've got 15 squared then, plus our b squared, that's our unknown value that we're trying to figure out here, is equal to 18 squared. Okay, so now we're just trying to solve this, and the first thing we can do is actually, why don't we just go ahead and subtract 15 squared from both sides. Subtract 15 squared from both sides, and we're going to get b squared is equal to 18 squared minus 15 squared. Which is, if we get out a friend here, because that's a lot of work here to do. 18 squared minus 15 squared is 99. Okay, 99. Which means that the length of b, if we take the square root of both sides, would be b is equal to, go back to our little friend here, square root of 99 is 9 point, we can round that to 9.9. 9.9 centimeters, right? That's the length of this little section from K to this center part right here is 9.9 centimeters. Now we can do the exact same thing with one of these other triangles here. If we know this is 15 and this is 27, we're going to set it up the same exact way. 15 squared plus b squared, it's still this second part that we don't know, is equal to 27 squared. Okay, so we're going to do this the same exact way. We'll subtract 15 squared from both sides. And we get b squared is equal to 27 squared minus 15 squared, which, again, I don't know what that is. So 27 squared minus 15 squared is 504. So b squared is equal to 504. And in order to get b by itself, we've got to take the square root of both sides. And we end up seeing that b is equal to, take the square root, 504, we get 22.4. 22.4. Okay, now this is really easy, right? We can figure out what the length of this whole distance KL is by adding those two together. So let's go ahead and do that. We've got 22.4 plus 9.9. We're going to end up getting 32.3. 32.3 is the entire length of KL. Okay, but we already said that we have a piece that's 36 centimeters long, so we need to subtract 36 minus 32.3, and that will give us the actual distance of how much left over we'll have after cutting that last owl. So 36.0 minus 32.3, we'd have to borrow here, we get 10 equals 7. 5 minus 2 is 3, and 3 minus 3 is 0. And so our leftover piece is 3.7 centimeters. And that's how you'd go about solving one of those types of problems. Last example here, it says that in kite ABCD, we have the measure of angle DAB. Okay, if we look here, DAB is 54 degrees. And CDF, this little tiny degree right here, is 52 degrees. We need to find the measure of each angle, okay? So before we actually start doing that, let's kind of take a look at what we know. We know we have two isosceles triangles. Okay, if this is truly a kite, that means that this side has to be congruent to this side, and this side has to be congruent to this side, which means that these angles have to be the exact same as well, right? Which means this has to be 52 degrees. And it means that these two have to be the exact same as well. So we could actually figure out what those are equal to by just knowing 180 minus this 54 will give us this, and if we divide that by 2, we will end up getting what those two angles are. And so let's go ahead and do that real quick. We've got 180 minus 54, divide that by 2, and we get 63. That means that these two angles are going to be 63 degrees. Okay, that's just certain things that we know about this isosceles triangle. Now we also know we can figure out what this whole angle is, right? We can know what BCD is, because 52 plus 52 is 104, and 180, this whole long triangle here, 180 minus 104 is going to be 76 degrees. Okay, and we know again that the diagonals make perpendicular angles, so all of these are going to be right angles. All right, so we've actually already gone about finding every single one of these angles, and if we look at the problem now, this is going to be pretty easy to solve, right? Measure of angle BCD we found was 76 degrees. Measure of angle ABC is just the combination of these two together, which would be 115 degrees. And measure of angle FDA, we already found was 63 degrees. Oh, cut it off. 63 degrees. And that's all you have to do, really. Just know the properties and know how you can use them. Sometimes we have to know properties about other types of things, like isosceles triangles, but not that hard to figure out. Okay, enjoy.